So hi everyone, this is our foundational course in data science with Python, and I'll first progress with Python. I'll teach you basic Python which is required for our project, and then we will move to data science with pandas, SciPy, and we'll also dig into a few machine learning algorithms and we'll build models using scikit-learn. So let's see. So we will do our coding in Google Colab. We are not installing any IDE or any Python in our local computer. We will do at the end of the course when we will build one complete pipeline to extract data, to transform the data, and to predict something. So we'll do at the end of the course. But for now, just to get a grasp, we will go with Google Colab. So here I'll create a new notebook. So Google Colab is a great tool where we can write our codes for machine learning and data science and Python and even TensorFlow, and it gives you one cloud connected computer with 12 gigabytes of RAM, few hard drive. So it's great. So even if you don't have a supercomputer or a powerful computer at your end, you can still do data science using Google Colab because that gives you the resources and that is for free. So that is getting connected, and let's name this notebook. I'm sorry, it's I don't know what happened to my computer, it's running slow today. Okay, so that is Python intro. Well, now, so as I told you, it has given us 12 GB of RAM and 107 gigabytes of, sorry, 102 gigabytes of hard drive. I think that's very cool, and that will be enough for our project. So with Python, I intend this audience for this course is beginner in Python with no or little knowledge. So we'll start with basics in Python such as variables, and we will also discuss about data types. What are the different types of data we can store in Python. Then we move to looping, and then we'll move to control statements such as if else and functions, and then we'll move to our data science course. All right, so here we will insert a new line of code. So this interface is like a notebook where you can write your data or you write anything. You can also run code simultaneously, so this is very good for presentation. People, even the great data scientists in the company uses it. uh, so I think this is a very great tool. An alternative to this, to install in a computer, we have called Jupyter Notebooks. You can also try that. And at the end of the session, I will also, like end of this course, I will also give you guidance how to install Jupyter Notebook and work with that. So let's start with variables. So what is a variable? So variable is a storage unit, such as you have, suppose you have something to store, such as one apple. Where do you store it? You keep it in a box. So that box will be variable, and the content of the box is the apple or the fruits which you have put in that box. So that is called value. So variable is used to store values. There are different other types of values which we can store in Python. So it may be a string, which is like your name. Your name is a string, or somebody's address is a string. Then there can be a numerical value such as 1, 2, 3, 4, or somebody's phone number. That will be a numeric value. And we have values of other types such as floats, which are like decimal numbers, 1.23. These are called floats in Python. And there are other types of variable as well, which we will go through this course. So let's start with very basic one. So suppose I'll create a variable called name, and I'll store my name into it. So my name is Sumit and this is the variable. Now this holds a space in memory. In our computer memory, this holds a space, and that is referenced by the name of the variable name itself. And when we use that reference, it will know what is the content stored in that particular location of the memory, and it will give us a content. So if we say name and if we run this code by clicking onto this little play icon, we will see its value getting printed. So it knows by the name of the variable which memory to reference, and from that referential memory it will know the content of that memory and it will show that. So this is the concept of variable. So we'll go deeper. So let's change this to my name. So note, I have made this variable name my underscore name and I have not kept it like this, because then this will create two variables and it will assign my name to both, because we cannot have spaces in our variable name. So I have to keep it one, and we can use special characters like underscore as well in our variable name. So this is my name, Sumit, and age equals to 24. So now one thing to look here is when I have written my name, I have kept that in quotes because this is a string value. And the second variable age, I haven't used quotes for it because that is a numerical value. So Python will treat this as a number and this is a string. So we will always need to enclose strings in quotation and numerical value without quotation. If we put a quotation with 24, then this is also of type string, and we can know this by using type and the variable name. So this will show what is the type of our variable, and that is called string. And if we remove this quotes, then it will show int, which is for integer. So that's great. So we now know two data types, which is integer and string. We'll check float as well. Suppose maths score, I scored 74.2% is in my mathematics score. So this is called float because we are using decimal number, and if we check the type, it will show as float. Yeah, so if you see like this, so any decimal number is represented as float, and we will see later on that when we add one integer with a different float, the resulting value will be float itself, because there will be data loss if we don't convert that to float. Suppose 74 plus 2, sorry, 74.2 plus 10, that should equals to 84.2. Now if it is not converted to float, then what happens, we are losing the value, so we are losing 0.2 here, and that will create a calculation error. So this is why this is converted to float. So the initial step is, this is already a float, this is typecasted as a float, which we will see later on this course, and then the addition takes place. So nothing to worry about this, we will see this in a later course. So let's do one thing, let's create a student report. So I will have student name, student standard. Suppose student is in 4th standard, and math score 86, English score 87, and French. Suppose the student has taken an elective subject French, and we'll see what is the score. So we have name, standard, mathematics score, English score, and French score. and we will try to print this out so that we can know what are the values associated with this variable. So what we do is we have a function called print that takes in any string or any variable name, and it will print the content of that variable. Suppose we want to print student name, we want to know what is the student name, and if we use print with student name in brackets, it will give us a student name, which is James in this case. Correct. So and if we want to print it like this, suppose student name is, then what it will do, it will, so it will concatenate that, it will add the student name after this string. So this string student name is, and a space is a string, and student name is also a string, so it will add James, the value of student name, to this place, and we will see that in the result. And as I said, it is correctly added James. Suppose student name was Matthew, it will add Matthew over here. So it is doing nothing, it is just adding that or concatenating that value which this variable holds here. Okay, so we have our student name. Let's go with standard print standard student standard. Similarly, we'll print scores. So instead of printing each score in an individual line, we will print it all together. So we'll print math, or let's do it below our subject scores for above student. And here we have mathematics plus. So since this is a numerical value, we cannot concatenate numerical value with string just like that. So we have to convert this numerical value to a string, and then we have to print. Oh, I made a mistake here as well. So even this is a numerical value, so we have to convert this to a string before concatenating with different string or with another string. So here we put our variable name, which is maths score. So this is very important, to convert your numerical value to a string first and then print it with concatenation. Otherwise this will throw an error. And yeah, after that, okay, and we have English plus str English score plus French plus str French score. Cool. Now let's print and see. Oh, there is an error. Okay, I made a mistake here. Cool. So we have our student report card here. It says student name is Matthew. Student is in 4th standard, and below the subject scores for the above student, wherein student has scored 86 in mathematics, 87 in English, and 17 French. Cool. So we'll now move with data types, which I think we have already discussed string, numerical, and float data type. We will see other kind of data types which we have in Python. So apart from string, float, and numerics, we have something called Boolean. So what Boolean is, Boolean stands for two values, 0 and 1. and Python it is called true or false. So it can only hold two kind of very content, that is either it can be true or it can be false. So suppose we will see is pass. So suppose we want to check if the student has passed its terminal examination or has failed in the terminal examination. We can assign a value called true, and if student has passed, then it is true. If student has failed, then definitely it is false, because if student has passed, student cannot fail. If student has failed, if is fail is true, then is pass has to be false. So these are complementary to each other. Both cannot be true. If both is true, then it makes no logic. A student cannot fail and pass at the same time. So if we print is fail, and if we run this code, we'll see the false getting printed. So that is our Boolean. And apart from Boolean, we will see other data types such as list. So what is a list? List is something to store multiple values. So here we have seen math score stores only one content, that is 86. If we assign something like 86, 70, 30 for multiple students, it will throw an error. So it did not throw an error because it converted all these values into a tuple. What is a tuple we will discuss next, but it is converting these values into a tuple. So list is similar of that. It will be used to store multiple values. So suppose I have student list, and this student list holds a name of all the students in a class. So list is denoted by the square brackets. So within square bracket we would put our contents, which is like Matthew, James, Ganesh, and Joe. Okay, and now we have another list. Student is pass. So this list will hold records whether the above student have passed or failed, and this will be of Boolean. Suppose Matthew has failed, James has passed the terminal examination, Ganesh passed, and Joe has again failed. So there are two students who have successfully passed the terminal examination, and there are two who failed in the terminal examination. And what we want to know is uh, how to link these two lists together, so that we know this first value is for Matthew, second value is for James, third value is for Ganesh, and fourth value is for Joe. So we can do that. So there is something called indexing, how we reference a particular value in a list. So list is indexed with zero position. So suppose we have this value Matthew, James, Ganesh, and Joey. So this is referenced as zeroth index. Similarly, this is the first index and second index, and so on. So if we had any other value, that will be fourth index, fifth index, and sixth index. Like how we count, we start counting from 1 to the number till it extends. But in arrays or in Python, the index or the counter always starts with 0. So if we want to receive this first value, what we will do is we will use the array name, which is student uh, list, and we will pass in 0. So this will tell Python to fetch the first value or the value at 0th index of this list, which is Matthew, and we will see value getting printed in output. And similarly, if the student has passed or failed, we can do that using the first index, which is 0, and we will know that student has failed. Great. Now what we can do is we can check for second student. Let's do one thing. We'll use print statement, and here as well. And let's see the output. So it says James true. So that means James has completed the terminal examination with green score, so that he has successfully passed the terminal examination and he has promoted to next standard. So from fourth standard he went to fifth standard, wherein Matthew, he remained in fourth standard because he failed to successfully pass or get the minimum passing mark for the terminal examination, and hence this is the result. So this is list. One thing to note, uh, this list contain all Boolean values, false and true, wherein this list contain all string values. So we do not see a list containing two different kinds of values. So suppose if we want to remove James, and we want to print true, and let's see what happens. And then let's see the type. So this successfully says that Matthew has passed the examination, Ganesh, and this is a string. What we can do is we can use list to store values into one list itself. So what we will do is we will remove this second list, and we will append values, Boolean values here itself, and alright, and we will just print the list. So this is like student name and the result, student name, result, and we'll see the output. So we now know Matthew has passed, Ganesh failed, and Joey again passed. Alright, so this is a list of multiple type of values, because this is string, this is Boolean. Similarly, if we wanted to indicate the score itself, we can say 70 out of 100, and this is 60 out of 100, and let's say he failed, say he got only 36. Alright, so this contain multi-value, multi-type value. So but this is yet not great way to make a list with different values, because we do not know if this value is really associated with Ganesh, because we do not, suppose we do not know at what index Ganesh is, then we will not be able to identify or infer that 60 is Ganesh's pass mark, or there is no connection between the number 60 and Ganesh, or number 70 and Matthew, or 36 with Joey. So we have another type of data type which is called dictionary. So what dictionary does is it has a key which will hold some value, and those two are related. So a key, when we ask Python that what is the value this key holds, it will always give us this value. Wherein in list, if we ask for Matthew, we will not able to infer that 70 is for Matthew. So what we can do is we can create a dictionary with suppose student score, and dictionary are represented with this kind of bracket. I believe this is called squiggly bracket, and we will type the key name as Matthew and its score which is 70. Then we have a key named Ganesh and the value is 60. We have key Joey with value 36. Let's add James as well with value 45. Alright, so if we print student score student score Matthew, see what happens. It says 70. So now there is a fixed relationship between 70 and Matthew. So if we say Ganesh, we will not get 70, we will get 60 because there is a fixed relationship between Ganesh and the number 60. So this is called key and this is called value. So these are keys and these are values. So the one on the left to this colon is called key and one in the right to this colon is value. We can also inverse this. So suppose 70 Matthew, 60 Ganesh, and let's delete this. Similarly 36 for Joey, and let's delete all these. So we are removing James as of now. And now if we want to check which student scored 70, we will see Matthew. Perfect. So we can still establish a relationship between these two values using key and value parameters. So now 70 is the key and Matthew is a value, and that is great. So we are able to have a relationship in this way. But one thing to notice here is key should always be unique. No two students can have the same key in dictionary. In real life, definitely more than one student can have the same uh, score, but when we are talking about dictionary in Python, keys are always unique, so they cannot have a duplicating key. So suppose even if this was 70, and let's see what happens. So it prints Ganesh. So what it does is checks which value the key 70 holds, and it checks Matthew. Now it goes to the second occurrence of 70 as a key, and it sees the value is Ganesh. So it overrides Matthew with Ganesh, and hence we get Ganesh. So if without referencing anything, if we just say student score, let's see. So you see we don't have Matthew in the list because it only holds unique values, and the second occurrence is overriding the first occurrence of that key, and hence Matthew is not printed out, but Ganesh is. So the key should always be unique. Values can duplicate, no problem. And with this we will move forward to a different type of data type called sets. Alright, so we will now move to create a set. So in order to create a set, we will require a list, and from that list we'll create a set. So what that set will do is it will take unique elements from the list and it will create a set of values. It can be string, it can be number, or anything else. So let's suppose we have a list, my list, that is equals to student scores 70, 40, 30, 20, 80, 70, 45, and 37. So here we see 70 repeats twice. Let's do one thing, let's repeat 30 as well so that we can find the distinction. Now what it will do is it will go ahead and select unique elements when we convert this list into a set, and we'll see that now, and we'll print this my set. So we see that our list had 70 twice, even 30 twice, but now in this we don't see 72 times. It only occurs once and even 30. So it consists of unique elements only. Similar to set, we have one more thing called tuple. So tuple holds two values, such as, I'll show this to you. So it is like Matthew 70, then it can be Ganesh, I'm sorry, I forgot, 30. Alright, now let's run this program and see. Alright, so this is called tuple. It holds two values together. So it is important in data science when we are analyzing values, and we have one key and one value. So this is not like dictionary where we had keys and keys were attached to the values or values were attached to keys. But this is very helpful in analyzing different things which we will cover later on the course. So this were our standard data types, which we can use in Python, and these will be very helpful while using this in data analysis further on to the course in pandas and NumPy. Alright, so now moving into our next segment called functions, sorry, loops. So what are the loops? So a loop is nothing but it does same things again and again. So that is called loop. So performing the same task again and again in repeat until and unless there is some condition which is satisfying the criteria. So suppose you had this student score, and it has score about 3 student, and we want to print each and every uh, student and its score. What we can do is, instead of printing it 3 times, such as print student score 70, then 60, then 36, what we can do is we can run a loop. So the syntax for loop is for value in container do something. So what it will do is it will take individual value from this container and it will do something with that particular value, and it will keep on repeating this task until and unless this container runs out of items. So we can see that here, suppose we have list, or we already have a list called my list. What we will do is we'll print each and individual value of this list, and instead of going through my list 0 then my list 1, what we can do is we can use for loop. So syntax is like for x in my list, sorry, in my list. So what it will do is it will assign the first value to this value, to this variable called x, and it will print x. Next the loop returns to 40 and it will assign 40 to this x and print x. Next it returns to 30 and it will get assigned to x and it will print x. So what we can do is we can simply print x. So if we run this, see, so we see 70, 40, 30, same values which are in this list getting printed here in each separate line. So what it does is it performs this task, which is to print the value of x again and again until the list turns empty. So once when the list is empty, it stops the execution. Instead of printing just a value of x, we can print something like this. Student score, then convert this to string and print x. So this will print student score 70, student score 40, and so on. So we have a nice way to print. What we can also do is just initialize total score equals to 0, and within this loop what we will do is we'll use total score equals to total score plus x. So what this is doing is we have initialized a variable called total score with numerical value 0, and when this loop starts, 70 is assigned to x, and it will add that 70 to this total score. So total score equals to total score plus x, that is equals to 0 plus 70, and it is 70, and this is again updated to the same variable called total score. So total score now holds 70. So next time the 40 is assigned to x, it is 70 plus 40, so this is 110, and that total score gets updated to 110, and so on. So if we do that, and if we come outside of the loop, and if we print total score, we will see the total score in this list, and that is 402, and that happens exactly as I have told you. Apart from this, what we can also do is we can find the maximum value. So what we can do is we can write an if statement. If x greater than total score, then total score equals to x. So what it will do is, if we have initialized a value, or suppose let's rename it as max score, because the name is confusing. Max, okay. So we have initialized a variable called max score with numerical value of 0, and we are assigning 70 to x. Now in this statement, if statement is a logical statement which will check the value of x. If this value of x is greater than our max score, then it will assign x to the max score. So here x is 70 and max score is 0. So 70 is greater than 0, and hence our max score will get updated to 70. In next loop it is 40, so x is 40 and max score is 70. So 40 greater than 70, it turns to be false, so this will be escaped, so this part will not run. So next it will go to 30, and unless it comes to 80. So now x is 80 and max score is 70, so our max score will become 80, and hence in this way we can find the maximum scores in the list, or maximum value in the list. So if we run this, we see 80 is the highest value. Suppose if we make this as 100, 1000, and let's run this again, we see 1000 as a maximum, and hence we can use loops and control structure. So we'll see more of a control structure here. So all we have done is, till now we have looped in with a list. What we can also do is, instead of list, we can also use string value. Suppose for x in Sumit, what we can do is we can print x, and let's see what happens. So it takes each character of the string assign it to x and print x. Again, it takes a second character, assign it to x, print x, and so on. So this is a nice way. And what else can we do with loop? So suppose we want to find any value which is greater than 30 and between 80 in this list. What we can do is we can assign for x in my list, and we can write an if statement. So that is a logical statement. It checks the expression here, and if that expression is true, it will run the code beneath it. If that expression turns out to false, it will skip the code beneath it. So suppose if we say if x greater than 30 and or let's make it 45. Okay, x greater than 45, we have passing marks of 45, and x less than 80. So if our condition satisfies that if the value of x should be greater than 45 and less than 80, if the value is greater than 80, this code will not run, and if that is less than 45, this code will again not run. And condition is this two expression should evaluate to true. If any of them evaluates to false, this code will not run. Or what we can do is we can go to the next line and then we can print x and see the result. So we see the only values satisfying these conditions of being greater than 45 and smaller than 80 is 70 in this list. So if we see, we have a value which is 45, but if we check the expression 45 greater than 45, this evaluates to false. And since we're using and conditions for and, both should be true. So since this is false, the entire expression turns out to be false. We are skipping this part of the code. All right. So suppose if we wanted to show in the output that if number is not between 45 and 80, then something else to happen. What we can do is we can use else operator, and we can print number not between 45 and 80. So it will print 70 70 as it printed for these two numbers, and for the other numbers which are less than 45 and greater than 80, it will print number not between 45 and 80. So 70 is greater than 45 and within 80, so it printed 70. 40 is smaller than 45 and hence it prints number not between 45 and 80. Similarly, 1000 is greater than 80 and hence this is the output. Apart from AND, we also have OR. So for OR, if any one of this condition evaluates to true, the code will run. And let's see. So all code ran because uh, 30 may not be greater than 45, but it is definitely less than 80, and hence this evaluates to true, and we are seeing the output. So in certain condition, when you want to find number between two different range, we should use and. Suppose if we wanted to be interested in any value which falls between that particular two conditions. Suppose you want to find a status of a message or status of a ticket incident as closed or in progress, then we can use or command where it will check for both closed and in progress tickets. Similarly, and can be used when the condition is like both the condition should satisfy. If any one of them does not satisfy, this should not evaluate, and hence we use and. And if else is used to you give the logical impedance. So if is false, then else will be executed. if else, what we can do is we can specify one more condition here. So suppose number x is less than 45 or greater than 80, and we're using AND condition, so it does not satisfy this if conditions and it moves to the next block, which is else if. What we can do is we can only be interested in something which is greater than 100, and only if this is greater than 100 it will print this value. So we want to print x here, and even if this statement turns out to be false, then finally print this thing. So we will see that since 1000 is greater than 100 and does not fall in this condition, so 1000 will be printed here, and all other number which is less than 45 or greater than 80 and less than 100, sorry, or yeah, greater than 100, it will fall in the else loop. So see, so 70 and 70 which were printed before, now one extra addition is 1000. Now all the numbers which were less than 100 fell into the last else block. Cool. So in the next session, we will start with NumPy, which is the foundation for data science. We will show how to work with matrix and arrays, and we'll learn more Python structures as well using those functions. So thank you for now.